All right. Hi, you guys. It's Professional High Priestess. I just wanted to say that for the most part, this coding tutorial is just going to be about going ahead and fully understanding what the coding language that everyone currently using right now is doing and how we're going to fix that, plus a follow-up to Fortran and Algo with the coding language called the Odinani. So what we're going to be doing is formulating these using specific sequences and then sending them to the planets that are carrying these floating points that are allowing for different space technologies to run on planet Earth. So when you're seeing things like ChatGTP and whatnot, just know that one of the things that they're doing is they're using LLM, large language models. They're using LLM and they're using NLP, natural language processing. So, you know, when you go on Google and you type in how to ride a horse, right? There's how to ride a horse, and then there's different things that can writing to say, is this talking about topics of how to ride a horse, right? So let's say, for instance, this doesn't have, if this didn't say how to ride a horse, it says getting on an animal and moving. You could type in how to ride a horse, and this will also pop up too, because natural language processor is saying that I'm processing the language that you're speaking. This is why they have chat GTP prompts. Yeah, chat GPT prompts. They shouldn't have shown their hand with this from space. And basically what the prompt says, you have to write in certain language. You have to write in a specific way and format to go ahead and activate like a language library that then goes ahead and pulls down disk images that make things up and then produce them for you. And but the disk images is off everyone's like data, because basically what they did was they have disk images. Like you have different database types and different coding capacities. They go ahead and scan what that looks like already in memory. It has like a format in already. And then they're able to find that throughout the computer and then go ahead and build programs off of that to maximize their libraries and their coding language. What ends up happening is the coding language ends up being able to run a logarithm that's talking to the processor, the preprocessor, and the compiler all at once to go ahead and activate a new Mantisa, which is another speech from space. It's just another type of electricity that's coming down through the CPU board. It's coming down through the culmination of a specific element in the metal and a specific element inside of the electricity, a type of ether, and then bringing down this ability for this coding language through natural language processing. So one of the things that's going to end up happening here is you guys are going to start to see like, oh, this is an alien language in an alien system, but we can go ahead and break it. So I'm going to go ahead and break that down. And the only ones that really need to work, I'll just go ahead and like save those. It's already done. They really just take the code and use it in different places. It's not necessarily on a server for some of them. And then this is going to stop them scanning everyone's data and like playing with everyone's like computer and things like that. And I'm going to go ahead and put something on the existing code. So they get their code. They think that they protected their code. They get it ran in these different algorithm things that they're building, and their code gets distributed to the program and whatnot or broken. So we're going to go ahead and just break all those floating points. I'm going to put speech down. Yeah, this portal's complete. Okay, so let me call down the number. Okay, so this is going to be my floating point that I'm going to bring down. And then what I'm going to go ahead and do is I'm going to bring down a Boolean to get me to true. Okay, so what I'm gonna go ahead and do, yeah, like this is fine. I'd rather it be capital. Okay, it won't, yeah, it was sending an error message the whole time. I'm gonna reformat. I haven't done my whole reformat for the syntax for lowercase yet. Okay, okay. So I'm gonna put down a Boolean loop, and this Boolean loop is gonna say that, there we go. Oh, ooh, there we go. So if I put -8, it's gonna print 0. Or if it's, no. Okay, so now why did I do this and why am I typing this all out? So when you're doing in their regular computer system, before we break the syntax for the computer as a whole, I'm typing it in this way to go ahead and start working in their system to bring down this floating point that I want to edit their ability to play with C++. I'm just gonna put it on here, and then the aquatic being she's gonna go ahead and like move this onto everyone's computer because she has access to everyone's like computer files and things like that on the planet. It's nothing to them because of the water portal that the internet is made out of. You guys have seen this before where I'm typing or coding things and then I save it and then my computer is like resetting and things like that and stuff is all moving around. So now what's going to end up happening here is I brought down a floating point and I brought this down. This is a Boolean loop. And basically I'm training like the logarithm of the number here. But like when you're playing in C, you can do the floating point that starts to bring down the mantissa. But really, you're going to do an array. You're going to do an array, a vector, and a vector just says that I'm bringing down this string of numbers. But what ends up happening is that's the octopus signaling the computer to start Mantissa 2, where it's eating a different type of ether. It's eating something that the electricity and the metal both make, and then they make it together and they make it separately. So they're bringing down different like magic from space, like, oh, they're bringing down different octopus that eat this stuff. And then what ends up happening is that they run number functions to then run in the computer with electricity because the octopus is like giving off a specific byproduct in that physiological process too. It's just like if you're running on a treadmill and it's powering up something. So they're not really telling you that that's how they've been running the computer. So just know that a lot of people are watching my channel. You guys have seen this already with stuff that's been going on and how people are getting hit up. Just know that it's going to keep on going on. So now I'm going to go ahead and get into variables, right? Now I want to get into vectors. Hmm. Okay. So what I'm going to go ahead and do here when I'm getting into a vector, it's just a specific way that you bring down numbers in a row, and you can start using those numbers to play. It's actually very interesting how simple this is, and they cause a bunch of drama with it. Um, okay. Here we go. Okay. So now, actually, here we go. And I'm just putting this because I'm going to save this as a file and I'm going to put like a global control so she can play with that too. And then like what I'm doing is I'm just opening up my computer to be able to edit a lot more of the settings and edit a network. Just use my computer to do that. Hmm. Okay. A lot is going on here. Okay. Yeah, this is still the same line. So I'm going to go ahead and start another command here. I'm going to change the order. Okay. Okay. Oh, I've initiated an array too. Um, Let me go ahead and put this up here. This is gonna come after right here. You're gonna do the vector first, and then you go ahead, and then you're gonna go ahead and do the logarithm first, because this floating point brings down the number, it that brings down a specific initialized numbers. That's what people use floating point. When you use just the integer that doesn't have like the decimal, you're just saying, oh, I have a number. And then you have to assign or unassign that number by making it a floating point or by putting it in an array. Then you activate the number to go ahead and start playing with Spellword, to start playing with this ratchet bitch in space that's like running the computer. Okay, so what ends up doing, what's gonna end up happening here is I'm gonna put this down right here. I'm bringing down integer main, right? And then I'm saying that integer main is going to head and open up a portal where I'm gonna start playing with integers, numbers here. I'm bringing down this array. This is a string of numbers that I'm gonna bring down just to activate the octopus, but I brought it all down in the negative. It's still going to go ahead and bring down a charge that I can use to work in the computer. But what I'm doing then is I'm setting up that entire flow with this right here to bring down nothingness, to shatter something, to shatter a box, to say no. So I said if x equals zero, that anytime you see x that's greater, a variable that's greater than zero, you're going to print a positive number. And then you can even put the range. All right. And then you get into randomization and things like that. Or you can say, anytime I see a number that's a variable that's less than zero, it's going to print another number. If I see anything else, I'm going to print zero. So I'm basically what I'm doing is I'm training this Boolean loop here to be um, to be in the negative. But really, all that I'm doing is saying that there's no access here. So I'm putting this in all of their coding systems so that the rest of their container picks this up and it's going to start to run like a no sequence, like no. Like remember how we said true with the little Kim song? You're going to run no sequences. So you're going to go here. You're going to go here and you're going to say, oh, You're gonna go here and you're gonna say, now that I've got this down, I'm gonna go ahead and bring down a BCD format number. Okay, so I brought all this down to start this negative, and I'm gonna bring this down the BCD format. And it's gonna be a tarot. Okay, the playing cards. Okay, I'm gonna bring down the Ten of Swords or the Tower. The Tower is the Ten of Wands twice. Okay, okay. Ten of Wands twice. Okay, so I'm gonna go ahead and bring that down in the binary space. Okay, so then what I'm gonna go ahead and do is I'm gonna say that, and I've brought this down here. And now what I'm also gonna go ahead and do is it's a Ten of Wands twice. So I'm gonna go ahead and string, let's see, I'm gonna string this together with another one. I can do math in my array. Okay, good. So what's going to end up happening here is I'm going to go ahead and bring down the tower. Now I want that tower to go. So I'm going to go at the end of this binary number and change it to a floating point, and then I'm going to put it as its own floating point. Okay. So I'm really playing with the BCD format here now. So now what I'm going to go ahead and do is I can now code down another floating point, which is just going to be this number. So I'm going to open up another integer space. Int equals uh, and then I'm going to initialize this variable, which is basically activated so that it can go ahead and start to work, uh, bring down a logarithm for us to go ahead and play with. Okay. So this is basically how now we're assigning an object, the tower, which is going to have an address and everything eventually. We're going to go ahead and bring down a number to go ahead and help us actualize that. And then we'll go ahead and use the decimal point. Yeah, as we can use a fixed and we can do a floating point too. If you do this with the floating point, then you're going to have to bring down another logarithm like this to help keep on shaping the logic, which is a breaking, which we can do again. So we bring this down again, and we can say that this is happening again. But this time I'm going to do 8. So x is okay. It could just be like this. It won't make a difference, but I just want to put 88. Okay, so now what's going to end up happening here is we're going to go ahead and we're going to do um okay, so we're bringing this down again. Okay, and now we're gonna go ahead and bring down the Ordomani operator. Okay, so the way that we do that is in bringing down two of the, we want to bring down two registers, pre-registers. Um, okay, I want to bring down YMM registers. Okay, so I think what I'm gonna go ahead and do is I can use two of these in Quadro format, which there's a syntax for these. This would be one of them. Okay, so I could bring these two down. Tie them together. Okay, and then move all of that. Scissor means that it constantly keeps on moving in full circles around the whole entire database until it encapsulates it to scissor. So move it into scissor. And you can do add. So you could add two registers, or you can go on here and say adding registers. Oh, the internet, you see, here it's about to go again. Okay, okay. So we're gonna go ahead and do that. Ooh, approve the tower. Okay, but let me start conducting it to um move right to chat GPT any AI because I'm using a natural language processing here. I'm using any AI. I've already activated those databases here. So basically what I did is I'm bringing down this floating point that's going to break and shatter their system. I activated the octopus by bringing down this specific array of vector. And then I'm going ahead and I'm training the vector by bringing down this type of Boolean loop. And I said that this Boolean loop is equaling to -8. It's no, it's negative. It's a zero. I could just say yes. I could just say true or false, actually. Hmm. Okay, so what's going to end up happening here is good. If there's anything else, it's going to print zero. So there you go. And zero, yeah, you can do this too. People don't know that in your Boolean arrays, you could say zero, zero equals false in language processing. Okay. Oh, you know what? Because zero, that's what also means that zero equals false. Okay. So you're putting it here false. So that's I know. So then I'm gonna bring down another integer array, and this time it's gonna be a BCD format, floating points, in binary for the tarot card. So now what's gonna end up happening here is I brought down the tower, which is through the Ten of Wands, and then I'm gonna go ahead and I'm gonna stop all this again by training the logarithm again. And then what I'm going to go ahead is I'm going to then bring down, now that I've brought down the container or now that I've infiltrated the container, I'm going to bring down macro processors that are going to go ahead and open up a specific like disk image inside of their database that's going to go ahead and like bring down stop the space floating points that they're using from coming down and like spinning a flower and then working with an octopus and then going ahead and releasing Mantisa to then go ahead and run like a program to go ahead and bring down disk images and database images that run like their database and run their internet and run their network system and run their messaging system and run their memory system. So that's what I just did right here. So now it's going to ChatGPT, any AI. Um, and I'm going to bring down the Odinani system now too. I did this all here. I did this here, all here. I'm going to do this again here. Now that I've opened this up. Okay. What I can do here is I'm actually going to put this at the top, the Odinani, and then I'm going to go ahead and do ASC control, ASC, and then what's going to end up happening here is I'm going to go pick up, whoa, okay, start of heading, SOH, and DC2. Okay, that's how you do it, start and then end. And now, some of the things that you guys are going to go ahead and see here is, um, okay, now I see how to do it. This is like not that hard. It's not. It's doing spell work on the computer. Now, what's going to end up happening here is I did go ahead and finish up this entire redesign. So when you're doing redesigns and like integrations, you use a geometric pattern and you put it over the system. And then from there, the geometric pattern will tell you how to organize itself. So I did all of these syntax sheets for the system. So people are going to come and start to see, okay, for electricity and memory, there's a syntax sheet. For database and system design, there's syntax sheets to redesign containers, database types, etc. We made it super, super easy. There's like a free space of memory, and then from there you go ahead and like program a container, a master container for like your operating system, that can like hold databases, have internet, etc., etc. And then like let's say for instance you can download an app and like even if there's no internet on your phone, the app will still work because it's connected to its own like operating system. You'll be able to do that, and then from there you'll be able to program different apps, and it's super easy. It won't be that much because we already have this on the internet. So let's say for instance, like how about the front end where we get boxes and like images and stuff like that? You could just go like this, which I would like to hire interns to do. I think I'm gonna hire some interns to do this. Okay. So yeah, woo. See, you know how to work with these kids. Yeah, that may okay. That may just be it. I may like hit up my yep, that's what I'm gonna go ahead and do. I'm gonna hit up one of my old interns. They're doing so well. I'm so happy for them. One of the things that I do every year is I go ahead and I take inventory and like not every year, but every time I get around to interns, I go ahead and I work with them and I give them recommendations and everything like that. But I also get their feedback and I have it for all of my interns. And I'm not going to pull it up because people are going to see this, but I'm happy that I've always had the track records with my interns and things like that, and I never really had bad experiences. So you could go ahead and do is, right, you can get this box and then make it like this. And then what you're going to go ahead and do is you can just copy all of this, and now you have the coding for it. So what you can go ahead and do is you don't even need to do that. You can go ahead and you can have it in a range. Yeah, you can have it 30 to 30, and then people can put like the number that they want, and they can see it change in front of them too, because you're having it here on the screen. There's a way that you can do that with just a database view. So you can go ahead and get all of these and then say, oh, I have these for like box sizes and stuff like this and button sizes and things like that. And people can just learn how to edit them. There could be instructions. And then you guys have it. There's other things that you guys can do. It's like for four different things. It's for this, it's for color, and going ahead and building up these type of systems, making ranges. Okay, okay. All right, you guys. So what's going to end up happening here is now we brought that down. We brought down these kind of controls to go ahead and put our computer in a specific state that we can go ahead and edit like uh, these different channels. I'm going to bring down a specific macro macros here that's going to edit the compiler, the preprocessor, and the processor all at once to bring down a specific disk image that's going to carry a database shape that's going to work with what I'm trying to bring down here. What type of memory? Let's see. Mm, okay. So now, another thing that's going to end up happening is you guys have you guys go ahead and you on your computer, you have your preprocessors and things like that, right? One of the things that people are going to find out is, oh, you can go ahead and find the floating point register, floating point control register. Yeah. So you can control all the floating points in your system and then you can expand them, find them, etc., through search, all of that. Now, one of the things that you guys are going to be able to do here is there's a specific system that you're going to have access to that allows you to move data in certain ways and organize data in certain ways. Like you can put down to SEE and you can say, I'm having this amount of data. I want to bring down this type of like disk image. You can bring down to, sorry, XMM. You could bring down one YMM and say that YMM is not on here. You could bring down one YMM and say that I'm going to bring down this amount of data that's going to allow me to go ahead and edit like several hundreds of gigabytes at once. Or you can use XMM that's saying, oh, I'm going to allow for the storage and editing and moving of just like maybe 20 gigabytes of data for your phone or your computer or a hard drive, all, a soft, a flash drive all at once. So there's another system for that where you could collapse that system and then you can bring them down to bring down different disk images. That's how it should be. And then to program that disk image into like, oh, okay, I'm down here, I have this disk image, meaning that I'm memory for like a computer. I'm memory for this or that, right? We're gonna bring down those right now too. Where am I? That word troll stuff. Okay, here you go. You're gonna have 8 of these, okay? And basically, why are these important? These are important because they say that after you go ahead and you start accessing the electricity, that's like gonna go ahead and run computer programs and allow for the memory to come down and be activated in the CPU so that when you turn on the computer, you know that you have a certain amount of memory that you could play with, that it'll take a certain charge and you could do these certain things with applications. One of the things that's going to come up here is this structure is important so that you can build different computers out of the computer that you already have. So what people don't know is that they can go ahead and like edit those disk images because it's just different flowers or octopuses or serpents they're playing on the internet, and that's all done for. That's all broken. So now there's going to be a new organization here where if you guys want to run any of these AI systems or any of this chemical server, you're going to have to go ahead and get permission because too much has happened on the internet with them playing a game. And now we can go ahead and rectify this with this system. You guys clearly have seen where I'm typing on my computer or doing certain things and my computer starts loading and uploading and changing. Let me see if there's any kernel tasks being run here. Extreme, yeah. Yeah, it's running. Let me go ahead and like make sure that doesn't take up too much of my CPU. It's taking more CPU than my Zoom. And that's a big thing that I'm running here. It's like there's several things all at once. My kernels are running in packages to reduce the amount of data that it's using. So the kernel task right here is running Zoom and it's running a bunch of other operating system apps. And then it's running the Zoom app and then it's running the web app, YouTube as well. And it's taking up certain amount of like processing power, right? So just like the example that we just gave, but that means I also edited my kernel tags, my kernels, so that they can go ahead and run a more complex um, programming on less data. So how my computer got like all frozen, the 808 once again, how my computer got frozen and how all of this ended up happening is I'm going ahead and I'm running numbers from space that are taking up a lot of information on my computer. So it looks like I'm running like a lot on my computer, but I'm running that extra kernel task to bring down these floating points and things like that so that we can go edit the computer. And that's what you guys are going to be going ahead and you're doing that too. Now, one of the things that you guys are like seeing is like, oh, this is all organized now. So now we can go ahead and we can say, oh, now I know how to move this around and now I know how to code and bring down all these different like commands and bring them down in order. Okay, so now what I'm going to go ahead and do is I'm going to bring down a specific disk image. Okay, so now I'm bringing this down and I have to bring down the syntax for the rest of them. So these are, mhm. Okay, so here we're going to go ahead and this one is this one, STX and ENQ. Yeah, STX is 1, 2, STX and then ENQ starts another one. Yeah, you see my computer's about to start tweaking.